Hey everyone, Sneaky here. So we're going to carry on directly from the last lesson. And that was where I showed you how to do infinite health, but it was only working on one character. So what we're going to do here, I'll show you how to get it to work on all the characters. And this way is technically not correct, but this is a beginner tutorial. And I'm showing you this way so that you can understand how the data we're working with actually comes across, so that when we move on to the next lesson, you've got a visualization of what's actually happening. Because if I just showed you straight away, you probably wouldn't understand it, and it would make the whole lesson pointless. You wouldn't be able to go, well, how do I use that for this? Do it this way. Get everything that you want working first, and then we'll carry on from there. Okay, so what we want to do first, we can do something very simple like declare some variables. So just for simplicity's sake, I will call my variable what my symbols are. So we've got local array. Now, this uppercase S is the variable. It can get confusing, but we want to use our read pointer and use lowercase because that's what I used in my symbols. As you can see, if I go back to this script that sets all the symbols, they are all lowercase. And notice I'm not using the square brackets around. That's because I want this base address, and that's all I want. But just that base address I want stored in this variable. So we'll do that for all 8 characters. So we have nucleo, we have rows, we have Edna, we have the misspelled easy, we've got Lila, Xavi, 2, 3, 4, 5, 6, 7. Who are we missing? Alicia. Alright, so now that we've got all of those, the way that we create this, so we can put this and do everybody's health all at the same time, we use if statements or control flow. So control flow is basically your code reaches a certain step. If certain conditions are met, then you run this code. If not, then you skip over. So it's just like doing a compare and then jump if not equal, or jump if equal. It's much the same as what we're used to in assembly. So a good example, we're comparing this for those 4 characters, jump if not equal to the next And then if it is equal, we'll run this code, and then we'll jump to here, and then run this, jump to return, and off we go. So that's using control flow. So if any of these, if EDX plus 90 matches any of these, it's going to move into there. If not, it's going to skip over. So we do much the same thing. So if array, then. So what we're actually doing is we're checking if this variable is anything other than nil. So it's quite easy. Let me just indent that so I can make it a little easier for you to see and understand. So there's the start of our function that we match the end to that. So if array, then set this variable, write that variable to that offset in our registered symbol. And then we can simply put end. So that's array done. So then we go if equio, then local HP, we can reuse that variable, read integer. We can reuse it because if it matches that, it will run and be used. And then the next time it will run, it will go through. Now, the reason we are putting end between everything and not else if, because if any of these ever match, it will never run what's down below. So we have to end each if statement so that it runs all of these if statements all at the same time. So what we need to do, put in every one of your custom pointers that you make, and make sure you get the correct offset. So, and then you write integer to your symbol plus the offset, which I believe is C. Yeah, it says it up there, comma, variable. End. Now you can type that out one by one for each character if you like, or you can make it a bit easier for yourself and just edit. So we've got Edna. Okay, I'm just going to fill these in and I'll be right back. Okay, so that's all of them done. Now that is a lot of typing, and even though I copied and pasted most of it and just edited 3 bits, well, that is a lot to do unnecessarily. But I have to show you what's happening. So we've got our variable that we're setting to our read pointer, and then our timer is running every 10 milliseconds with this set interval method, and then using the onTimer property, we run a function, and a bunch of if statements that are all independent of each other. No else in there. I'll cover if then else in another video, but for now let's keep it simple. So if array, then set this variable with that value that's in that offset, and then write to this value at that offset what we've stored in that variable. Now when I run this, let me just double check that's the correct script. Yes. So when I run this, you see all of their health just got filled in. And because it's running on a timer, we all have infinite health, so they're just going to automatically fight, but not a single health point was lost. So that's how we get it to work across multiple characters. And I did mention that is the incorrect way of doing it. So let's go over the correct way of doing it. So what we want to do, we can scrap all of this code. That was just an example to get you to understand what's actually going to be happening every time this code is run. So what we have, we're going to now touch base back on Cracker's lessons. So the first thing that I want to set now above my timer, so we'll move that to the bottom. I'm going to create a table. Now this is just a very basic table. We're going to store it locally. I'm going to call it chars equals, and we define our table by using these curly braces. And then what we want to do here, because we want to use the information we're putting in as a string, so we put exactly the name of what we called our pointers, but the memory that we allocated. So I'll just go through and type all of them out so you can see how it's done. Remember to put commas between each one. And make sure that you spell them correctly. So exactly as you type them in your initialization script. However you've registered them, they must look the same. Right, and I left the comma out of this one. That would be quite catastrophic. So what we want to do, we now need a function. So we've got our table. What do we want to do with our table? Well, we want a function. So again, we just call it a local function so that we can reuse the name in other scripts, and so that information that's in this script doesn't get messed with by other scripts if we do happen to use the same names. So we go local function, and then we'll just call it set chars. Put 2 brackets around it, and then so remember to put the end so that you don't mess it up by not finishing off the function. Like Cheat Engine will tell you when it's messed up, but it's easier to just remember. So what we do with the function, basically anything we put between this word and this word will run every time that function gets called. So we want to use a loop to go through this table. So our loop will say for k v in pairs chars do. So for key and value in pairs, and we're calling this table in our pairs. For now, let's just see if our for loop is actually working. So print k v. So k will be on the left, v will be on the right. Remember to end your loop. Let's hit OK. I didn't tell it to call the function, so we must call it. It's as simple as typing out what we did. That's how we call the function. So let's call it. Now we'll bring this up. So you can see here, just a quick recap on what Tracker taught us. The key is 1, 2, all the way up to 8. Now because we didn't specify it, Cheat Engine has, or rather LUA has totally populated the key for us. So we've got Saray, Nicleo, Rose, Alicia, Diesel, Lila, Edna, and Zavid. So by using print, we can see that our data is coming through how we want it to. And if we were to call chars and then put a square bracket for, it will print 8 times because there's 8 objects in this. So it's going to run through 8 times this loop, because for however many k or keys, we've got 8, matching a value, which we've got 8, in this table, do, and we're printing this table at key 4, what value is in key 4. That's why it printed 8 times. That isn't very helpful to us as a cheat, but that tells us that our loop is working correctly. So you can save yourself a lot of headaches by using print to see that each section of your code is working before moving on to the next. So what we want to do, now that we've got our loop working correctly, create another local variable, call it HP equals read integer, and make sure you spell it correctly. Now, this is where things get a little bit tricky. We're going to use some concatenation here because we need the whole thing to come out as a string. So we use our single quote, square bracket, single quote, because we need to get that around here. Use the concatenation. We don't want to use the key, we want the value. So we use v, concatenate, single quote, close the square bracket, and give our offset, which is 2BFC. Close the single quote and close our bracket. Now what we can do to make sure that that's working correctly is print HP. And we end up with our HP values, or max HP values. But we also end up, because there's 8 characters, but we've only got 3 active in our party, we've ended up with some nil values. And I'll show you what I mean by that. So if I go type, and if you're ever unsure what type a value is, just type. So number nil nil, number nil, number nil nil. So how do we get around that? We use control flow. This one is a very simple example. So if you wanted to perform arithmetic on anything running through this function, you will come up with an error every 10 milliseconds in this case, because you can't perform arithmetic on a nil value. So even though it may not be necessary in all cases, I highly recommend you do if HP then write integer. And now we want to write to these the same way that we read from them. So that's single quote or double quote, your preference. Just make sure you use the same one to close as you do to open. Dot dot to concatenate, V, dot dot to concatenate, single quote, close bracket, offset C, and close the string, comma. We want to put HP into that offset. Close the bracket, so we won't get all sorts of errors with our code. So we can run that inside of this function, and this is just doing the exact same as the previous code, but instead of doing it over and over and having to write that constantly, we're just looping through one instance of naming. And as you can see, because I left the print in there, it keeps printing. So we'll just remove that. We can see that the health is still full. And I'll just go find an enemy. And I'll just leave them to do nothing. No health loss. Now, one other thing I want to show you before finishing up. The reason I would recommend doing something like this over the top of what we did previously, putting those in individually. So we can actually do some compares with what we've got. But this one-hit kills, for instance, this is done using nothing but assembly. Now, let me just leave that there for a few seconds and see if you can spot the mistake. Okay, now the mistake is I've gone through and I'm comparing all of my symbols against EAX. That's not the mistake. I was doing that one by one though, and I've actually left one off. So what happens if nothing matches? That's going to jump down here and automatically write 0 into the health address. Now, even though my infinite health script is going to be writing the top value in, if the character that's missing isn't in there, they're going to die straight away. So I could easily fix that by copying another block and fixing it with the symbol. But there is another way. We are doing this, a combination of assembly and LUA. So I've just gone through, there's my AOB scan, allocating the memory, allocating more memory for a multiplier. We are initializing the multiplier, and then we put LUA. Whenever you put LUA, if you don't intend to finish off with LUA, always put this underneath and give yourself some room and work between them. So here's the table again, all the characters. Here's the function. So I use I instead of K in this one. You can use literally anything. You could put whatever you like as long as you reference it. We are setting char, and then if char, then I'm using the auto assemble command, and I'm giving it a string jump to new mem. So if this gets populated by one of these, and we are just reading the pointer, we want it to jump to new mem. Jump to new mem, multiply, then run the code. If it doesn't, then we jump straight to code. And that's how we can save. So this one hit kills. This one hit kills here. And I made a mistake and I left one out completely. By running it this way, you've only got to do that. And as you can see, you can just copy and paste. This is why I'm using local variables, local functions. Using all of this, you get it right once, you can copy and paste it into all your other scripts and reuse that information in other areas. So it doesn't have to be limited to just health, and then you've got to go write a whole new script and assign a whole bunch of new symbols. No, that's not it at all. Like, you can tell it to run this part there, and this works as, so every time this gets run, just like running your normal cheat, what you're used to in assembly, this whole thing will run every time. I hope you learned something, and I hope that wasn't too big of a jump for you, because that's stepping into intermediate territory now. It's very basic loop, but in order to create these codes as you move forward, you will want to use loops, and this was probably the best way I could kind of give you a friendly nudge in the right direction with concatenation, understanding what this part actually means. So we're reading from this table. V is whatever's in here for each one that we've got, each index. And because we haven't written our index in manually, we could actually use iPairs, but safer to just use pairs until you really understand what's going on. I'm going to wrap it up here, and you have yourself a lovely day. As always, contact me on Discord. You can find me on a cheap game Discord. And if you have any questions, just drop them to me. I'll get around to answering them. If this is too hard to explain, I'll do my best to get you to understand it. I know that some people won't learn the exact same way that everyone else does, and I'll do my best to make sure that you can understand it. All right, see you next time.